Welcome all to this second webinar of 2024. I'm Scott Whitty, and I have the honor of serving as president of IVRPA, along with an exceptional dedicated board of directors, such as Jeremiah Scott, who you'll be hearing from in this webinar. IVRPA, the International VR Professionals Association, is the only international association dedicated to helping our members and the wider VR XR community of creators be more successful in their field. This webinar is a great example of that. Digital twins was a market of $17.5 billion in 2023 and is expected to grow to $154 billion by 2030. Most of that is pre-visualization done with programs like Unreal Engine and the like, but much of it is documentation of reality, such as construction, design, archaeology, architecture, urban planning, and manufacturing, which will be the focus of Jeremiah's presentation. Digital twins is an area that most of us could work in, yet I bet most of us are a bit clueless about it. Making us less clueless is an important part of what IVRPA is about. This webinar is being recorded and will be available to paid members on the IVRPA website, along with a collection of valuable webinars on various topics. If you aren't a member currently, I encourage you to join, gain access to that and a good deal more. Let's see. Beyond the webinars, we have an annual in-person conference that will take place in Las Vegas in June. Lauren Price, who's leading the conference, will have more to say about that at the end of the presentation. If you want to put something into chat, be sure to click the blue button above the chat window or to state who you want it to go to. If you don't, it will likely only go to the webinar presenters. If you want it to go to everyone, select everyone. And for the most part, I would encourage that. Let's see, what else? Okay, the floor will be open to questions at the end. Now let's go to the main act. Jeremiah, sorry, take it away.
All right, good morning, everybody. Thanks for joining in. Excited to be able to share this presentation on what we do at Boeing in terms of 360 photography. I'm going to give you a little bit of background here on who I am, where I started with IVRPA, and kind of the story of the service that I put together at Boeing. I'm a tech fellow, a technical fellow at Boeing. I've developed a service, a technology, and a platform that supports hundreds and thousands of users every single day. We had 325,000 internal visits in 2023. We support the Boeing lifecycle in terms of everything from the design, the manufacturing, the test, the build, and the sustainment of the products as they're delivered. So we talked a little bit about how those use cases fit, how 360 photography supports those, and how my team provides that capability. We developed a number of technologies internal to Boeing, which enable us to support specifically those use cases. We worked with a lot of different COTS products or commercial off-the-shelf products over the years, and I'll talk a little bit about that journey and why we developed our own internal capability. We capture every Boeing product, everything from space and launch to BDS products like Apache and Chinook, to commercial airplanes, 737, 47, 67, 87. Today, I'm going to be focusing on the BCA aspect of it, so Boeing commercial airplanes, but these use cases generally also apply to defense and space, and then Boeing Global Services, which is our sustainment platform as well. All right, so in 2013, I was lucky enough to learn about IVRPA. I couldn't tell you exactly how I found out about it in the first place, but I was able to get Boeing leadership to approve a pretty extravagant trip for me at the time to go to Iceland and join in for the conference in Selfoss. It was an amazing experience. I met a lot of you and many of the experts in the field who helped kind of mold and provide a lot of technologies, use cases, and exposure to different aspects of the 360 photography process, which I was then able to bring back to Boeing and start building a capability and then eventually a service. In 2011, 2012, we started getting involved with PanoScan. It was the first 360 camera that we started using. It's a pretty amazing platform. It's essentially, if you think of like a flatbed scanner, it takes a line scan. In this case, it just does a line scan circling around the nodal point. So it's a single scan of your scene. It creates some really amazing images. There were several side effects though. Things like flare come out as a pinpoint streak vertically across the equirectangular. It comes out as a single image. There's no option to go back and pull from source images to recreate what was originally there. And then the resolution is capped. So you can't put on a longer lens or you can't put on a different system to increase your resolution. So we did use that for a number of years. PanoScan became a very known term around Boeing. So when we delivered something, even today, we get many users who are saying, "Oh, you're the PanoScan guys," and we're like, "No, we don't actually use that anymore." But it was a great camera system. We learned a lot. We made a great service out of it. And then as the technology started developing and expanding, we moved into a gigapan, which was fantastic because we could basically scale to any resolution we wanted. But with the large base, we really were hamstrung as far as the nadir, the bottom of the 360. So it ended up being a lot more processing time, but very beautiful results. So the capture time was longer, especially when we shot HDRs. You'd end up with hundreds of pictures for a single 360 to stitch and then process. And so as our volumes started increasing, it just became untenable. So as became more introduced to more of the team members around IVRPA and the international groups, I started learning about Nodal Ninja, and that's actually what we still use today. Nodal Ninja is fantastic, great calibration hardware, allows us to maintain the same Nodal Ninja rig using different hardware, different cameras, different lenses, and we've been able to scale and change with it over the years. It's been a great piece of hardware. And then integrated service. So we started with things like PanoWeaver and some of the early 360 COTS software. We used color software, Auto Pano Giga and PanoTour Pro, which were fantastic systems. We had great support from the color team over the years, being able to customize and develop new plugins to support different use cases. Unfortunately, of course, when color went out of business and was dropped by GoPro, we didn't want to leave ourselves stranded. So we developed our own internal capability as far as a development team, which now supports our own internal platform, which we call Apex, Advanced Photographic Engineering Experience. Essentially, it's a platform that supports photographic visualization across Boeing. We take internal Boeing data sets, things like part numbers, IPs, installation plans, and things like complex engineering drawings, and we're able to associate those with the real world photographic record of those locations. So things like when you have a non-conformance report, something wasn't installed quite right, or we had a part that was changed out in manufacturing, we can show the text of that record relative to where it's installed on the aircraft. And that connection enables a lot of different processes to be able to improve engineering, to be able to provide the as-built visual record compared to the as-designed visual record. And I'll show that in a few minutes. But it's been an amazing capability that's really expanded and improved the communication across the value stream for Boeing. So here's a couple of those use cases. As a quality systems specialist, I need a web-based physical view of the airplane in order to drive defect containment so that the mechanics, electricians, and inspectors can communicate first-time quality checks back to the installation, plan, and reduce repeat problems in the airplane. So the example there that's being shown is inside the wing tank of a 737. So we're climbing inside of a wing tank. In this area, you can actually fit fairly well in. It's pretty compact. You have to get special training and suits and all sorts of requirements and training to be able to get in there. But physically, it's a pretty small space. And so as you get further and further outboard on the wing height, of course, gets smaller and the length gets smaller. So we end up having small access holes that we actually just pop the camera up into. And as it gets even smaller still, we use things like the Theta or the Insta cameras to fit in very, very small spaces where you can't even fit your head into. But that allows us to get access and photographic records of the build in small spaces that people can't visually easily inspect or really understand how we actually build something and relate it back to the drawing definition. So when we have things like we want to improve a process, we want to change the order of operations in which something's assembled, providing a design definition, a 3D model of it is fantastic because we can order it out and lay it out, and we can even do things like see if the part will fit in that space or figure out how to lay out how the part gets installed so that we can position it and fit it into that location. All sorts of things like ergonomics are supported that way. But again, that's the design definition. So when we change it from the engineering to the physical real world, we still need to prove and validate that the real world is what we say it is. So what we're doing is providing a photographic record of the build, which then informs the design definition so that we can improve it and continuously make better products and better engineering. So the next one is, as an interior design engineer, I need a clear and accurate visual record of the airplanes that we build and deliver so that I can guide future airline customer decisions and enable Boeing design improvements. This example here is for a 787. We call it FOM, stands for first of model. Essentially what happens is when an airline or a Boeing customer buys an airplane, they don't generally just buy one. Maybe they'll buy 30, let's say, for example. And what they'll do is they'll have 10 of them with a specific configuration. Say they want red seats, right? And then we do another 10 with blue seats and another one with green seats or whatever it is. So they'll have different configurations supporting different flight plans around the world, different capabilities depending on the type of customers they want to support. Different routes, different mission capabilities, all sorts of things like that. And so for each of those configurations, the first airplane delivered is the first of that configuration, first of model. And so for each of those first of models that are delivered, we capture a full 360 virtual tour of those specific aircraft. So we have the specific line number, the specific customer, all of those things are documented in the photography of those images and delivered as part of our internal Boeing processes. Those help define and show what was actually delivered to the design engineers. So, for example, when an airline goes to buy an airplane, it's not going to be delivered the next day. So engineering doesn't actually get to see what they delivered in many cases. In some cases, it could be 10 years before the airplane ever even gets into production to be built and delivered. So when engineering puts together the design definition, the 3D model, the interior layout of passenger accommodations, all of those forms and features and functions are predefined in the drawings, in the models, in the visual indications of how to build the aircraft. And then what gets delivered, they never actually get to see. So we started about, maybe 60 years ago. We'd come out. Same team, we would come out and shoot 4x5 film, or we'd shoot medium format film, or we'd shoot 35mm film as technologies got smaller, and we'd provide a photographic record of what was built and delivered. And over the time, those got converted to a web page, so you'd have a gallery of all those stills for each one. And then as 360 came along, we changed that to be able to support a 360 view. And what's been fascinating about it is, yes, they need to see all those details. They need to see how the passenger cabin supports, like let's say the remote control for the video game system or your display in front of you as you're flying. Those are neat forms and functions, and be able to see a little detail of it, but being able to show that in a 360 is an amazing capability. It gives them much more context as to terms how those users go in and access that, what it actually looks like, what parts, how the cords fit in there, all sorts of design functions and features that the engineers are able to then go reference and share with future airline customers to show them, hey, here's how what we designed was delivered. Do you like this? Is this a different feature you would like to include in your airplane? So things like the 3D walkthrough or the 3D simulations that we show to customers are fantastic in helping them understand it, but being able to show them and prove to them that a photographic record shows those same capabilities, or what it actually looks like with the interior lighting, is an amazing, very functional capability that we support. So to do that, we have photographers out on the flight line every single day capturing new images of the airplanes that are being delivered. So we have generally between 2 and 4 virtual tours delivered every single week for each of these first of model aircraft across BCA. So 737, not 47 anymore, but 67, 777, and 87. And so, of course, those are freighters. Those are interior cabins. And then we have a predefined set of capture locations where we go through and capture those. And then in this example here, you've got these little square icons. Those refer to our gallery stills. So each of those detailed stills, like we used to shot way back in the day with film cameras, are also captured. But instead of just a gallery of detailed stills, we can show the context of where those stills were taken. I know this is kind of obvious for 360 shooters, but things like showing the PSU, the passenger service unit. This is the thing above your head that has the air, the light, the stewardess call button, things like that. We show a photographic record of how that was installed, what it looks like. Those kinds of features are installed to show where those are in the aircraft. So if you open a stow bin, or you open a safety console, we can show you exactly what was installed in that when it was delivered. So each of those kinds of contexts provide better value to our engineering teams, to our users. So it's not just a 360, it's based on what was actually photographically delivered. So it's a different mindset in terms of use case for 360. It's not just making a pretty picture to show marketing. It's a engineering tool to show what we delivered. So one of the things that often comes up is, hey, what if we just created a swatch of carpet patterns, and we could take them into the studio, we can make these beautiful pictures of carpet patterns, and we could take those and light them the exact same way they're lit in the airplane, and we could make it easier on ourselves to retouch these. We have a retouching team that goes through and corrects chromatic aberrations and distortion and the nadir and the zenith and all sorts of retouching capabilities that allow us to provide these gorgeous images. But one of the foundational functionality requirements is that we're not making a pretty picture. We're creating exactly what was delivered, period. So creating a bunch of swatches and examples of the carpet patterns may make it much easier for the retouchers to say, I need that one, and to place it. The problem is that's not actually what was delivered on that specific plane. So making sure that, because we have such very high resolution in these images, making sure that what is in the image is exactly what was delivered is a very important piece of the record. All right, moving on, we've got, as a systems engineer, I need an accurate visual record of the latest modifications on a delivered aircraft so that I can ensure future modifications are not impacted or impeded by my previous efforts. I use visual data to ensure our drawings and aircraft configuration do not conflict with each other. So this is a really interesting one. In many situations, we deliver the aircraft and it goes off and flies for many years, but it gets modified. Say in defense and space industries, like, for example, we'll deliver the configuration that was requested, and then the and then the operator will create a new capability that they want to install in the aircraft. So they do it. They put it on their aircraft. They can do whatever they want. But then they come back to Boeing in, say, 10 years, and they say, we want to update our flight deck from a analog flight deck to a digital flight deck, which is a completely, yes, the displays are different, but you have all of the wiring, the systems, the antennae, the architecture that supports that, that go throughout the entire airplane. So in order to run those wires, in order to put in that infrastructure, to put in those electronic units in the electronics bay, we need to be able to know exactly what was there so we can engineer it so that it'll support it. And so one of the big challenges is what we delivered to the customer is not what it is now. So we have to go back and create a photographic virtual tour of those current conditions to be able to support engineering. And many times those projects will last 5 to 10 years. So having a photographic record, not just somebody's memory of flying out to the airplane and taking detailed pictures, but a complete comprehensive photographic record, what's behind these sidewalls, what's under the ceiling, what's under the flooring, helps define exactly how to create first-time quality for engineering to be able to install those capabilities. All right, like I'm flying along here. All right, so this is kind of a nice little demo. Scott mentioned earlier about the digital twins. Essentially what a digital twin is the design definition of what is built, completely modeled in 3D. That allows us to plan the engineering. It allows us to take individualized parts specific to that aircraft and show what it looks like in 3D space relative to aircraft coordinates. It's an amazing capability. It allows us to update the design definition based on what's actually being installed. So whether or not a part is there on the 3D model, and reflect that based on whether it's actually installed on the aircraft. So being able to update dynamically the 3D model based on what's being built. Of course, you can add in all sorts of metadata, things like the part numbers, the IPs, the engineering drawings, things like that can be associated with each individual part for each individual airplane. But then functionally, you still need to take what's designed and relate it to what's actually being built, and to be able to prove that what we're designing is what we're making. So this is a technology that my team developed that allows us to relate in 3D space. And these are two different applications. So we have an internal 3D viewer that is showing a specific aircraft for a 787. And on the right, you have the 360 virtual tour. And so what you're seeing is as we move through this space, it's updating the physical as-built viewpoint and sending those coordinates and that vector over to the 3D model. So you can dynamically move through the space and compare that, yes, this is that part, and here's what it's meant to look like. Here's that wire run. This is exactly what we meant to run that wire, and here's what we were designed that to do. So you can jump through anywhere on the airplane. It's been an amazing tool for engineering, for production, all sorts of use cases. Here's the main cabin on the 787. We're just moving through, and you can see how this updates the design definition. All the systems and wires that run under the floor, of course, those are not seen just because we have the we call them PS floorboards, the safety protective equipment over the floor. So things like this enable us to compare the as designed to the as built, and you can see how some of those capabilities tie together. It's been a pretty exciting capability. What we're doing here is we're taking the station waterline buttock line. It's a 3-point location relative to aircraft coordinates where the camera was physically set up in that space. And then we that's your point of origin, and then we have our vector, in other words, where you're looking at in space from that point of origin. We don't need to know exactly that coordinate point, but we just need to know a starting point to create the relationship between where you're looking in the 360 view to the design definition. They're two different coordinate systems, and there's different coordinate systems based on where you are in the airplane. So there's all sorts of nuances with this. We have to convert a localized coordinate system to a global coordinate system. and then create the API interface to connect the two different applications to talk to each other. But essentially, you're taking a repeatable process where you're capturing a 360 image in the same place every time, stitching it in the same way so that you know which way forward is, localizing that forward location between the two applications, and then taking that image and including the IVT or the design model coordinate locations into the metadata for that image so they can talk to each other. So those kinds of capabilities are really exciting for enabling digital twin and grounding our design definition to the real world. All right, hardware and processes. How am I doing? Okay. So our hardware kits, we're currently using a D850, which is unfortunately at end of life. Thank you, Nikon, and a AFS 8 to 15 millimeter zoom lens, which is not ideal, but as most of you know, the being able to maximize the field of view for a lens on top of the sensor to create the little black borders around the edges and the corners allows us to maximize the resolution we get and balance it against the number of shots that you need to get that resolution. So we run into some interesting situations where we want we never can quite find the exact lens we want to support the use case we need. So we've been looking at going to manufacturers to build a custom lens to support higher resolution and limit the amount of distortion and chromatic aberration and things like that the fisheye or the zoom lenses often create. We use a wireless trigger to trigger the camera without having to bump it. We use a tripod, I hope everybody does. And we also implemented color checker cards, which as we got more and more use cases to support, we found that the color matters. We wanted the lighting systems and the teams that put together the interior lighting for, let's say, the lavatory versus the galley versus the main cabin versus the cargo areas. All of those teams pay a lot of attention to the quality of the color. And so while each person views their screen on a different monitor, and those monitors are generally not calibrated, we do make sure that what we deliver as you move from scene to scene or 360 to 360 balances and matches with what we also capture in our stills. So we use a calibrated color card to apply those color densities between each of those areas as you move through the plane. We use a tape measure to make sure that the camera height is exactly the same between each capture. So we have a consistent viewpoint, both for our digital twin alignment and for our localization in our navigation. So in order to deliver 2 to 3 to 4 virtual tours every week, all of these things have to be very well defined and clear, both for our photography capture teams and for our retouching, processing, and tour building teams. All of these processes have to be super clearly defined so we can meet our quality requirements as well as our delivery timeframes. Everybody wants their, I'm sure you guys know better than I do, everybody wants your tours out as soon as you can. The next day will be great. So we're trying to get our times down and create metrics to help show a faster delivery time while not losing any of your standard quality. And then, like I mentioned, we're using the Nodal Ninja. We use an X-ray monitor calibrator for each of our processing teams to make sure that we have a pretty what's the word? Our team members are all over the country. We have team members in the US, I'm sorry, team members on the East Coast, in California, in Texas, in Puget Sound. But a lot of these team members, some of them work on Boeing sites and some don't, some are remote. And so being able to support those team members and have all of the images come out the same way requires all of us to use the same monitors, same color calibration, to be able to ensure that when one person processes it on the East Coast versus Texas, that the images come out and are consistent so that we build the navigation. There is a seamless integration as you move through the tour. We generally use Adobe software for our image processing, Lightroom and Photoshop. We definitely use PT GUI for our standard stitching. They have great results. Their updates are consistent and really providing a lot of value for us in terms of the stitching quality. And then we have our internally developed Apex software, which has all sorts of Boeing requirements as far as which capabilities can be implemented and used in it, and how to connect our software with Boeing's data. One of the challenges we ran into early on was, as we learned more about the use cases, how what data that our users needed to access. Say, for example, somebody on the floor that needs to look up a part number. They'll have a part number, but we want to show where it is in the tour, or we want to show where it is on the airplane, or we want to show how an installation is actually installed on the airplane. Things like that, they have to access multiple data sets. They have to access engineering drawings. They have to access the manufacturing execution system. We have to access all these different applications, which then create friction in trying to get their job done. So better understanding of your use cases and your users and what they need to do enables us to build software and applications that makes it easier for them. We don't want to give them another thing to do. We don't want to make them a pretty virtual tour if it's not going to make their job easier. So what we do is we go in and connect those data sets into the tour so that we can just go to one place and have all the data dynamically updated based on what they want to look at in order to do their job. You can't do that with COTS software. It won't let you add in iframes upon iframes and still accept a reasonable performance capability. So we integrated those backend data sets directly in so we can have better performance and dynamic loading. So we're not just having static data that you just update once. It has to be updated as designs change. We also have identified documented processes. When we started on back in Iceland, my idea was we could just have a bunch of photographers shoot it and process it and deliver it. At the time we delivered our first virtual tour, it took us 1.5 years to do. It was a massive effort. It involved over 250 scenes. It was our first time doing it. We didn't know what the heck we were doing. And then as we really streamlined our processes and really structured our capabilities, we were able to define specific processes, skill sets, and requirements for each of these capabilities. So we have our photographer role, we have our Lightroom processing, our color grading, stitching, retouching, and then quality ensures that we're meeting our image quality requirements, inputting and delivering things like the nadir, the retouching, making sure that we're not making up a fastener when it wasn't actually there, being able to validate that what we're delivering in the image is actually how the airplane was built. So we're going through and validating against the source raw images, against the 360 images to make sure that we didn't accidentally create something that wasn't there. We have a standardized tour build. Like I mentioned before, our standardized shot lists are captured ahead of time, so we know where we're going to be capturing images when we go onto the plane, and then those local coordinate systems are applied throughout the build process. So when you move through the virtual tour, you're not just moving forward or back or left or right. You're moving to a specific station waterline buttock line. So those are annotated, tagged, and built into not only the user interface. So we have the users going to a specific station waterline buttock line, but they're also built into the scene names themselves, the image files, the metadata. All of that information is stored and saved so that when a customer or a user comes back in 5 years and says, hey, this doesn't look right to me, we can go back and validate it against what was actually recorded in the file itself. We have customer review and approval. Each of our engineering teams review what we're delivering to make sure that what we're delivering is per specifications, per requirements, and meets the user needs for our users. And then all of this has to be maintained. So it's not just, we're not just delivering at one time and saying good luck. We're maintaining this application every day, all day long. We have IT support, we have engineering support, we have users giving us feedback as far as service outages, all sorts of things. And then, of course, we have government and Boeing compliance requirements for security, things like access controls for who can access what. Some of the programs are very sensitive, and some of them are open to Boeing and their customers. And we have metrics for ourselves to make sure that we're performing to plan. And if we need help in some areas, we're going to see, hey, our capture times are going up, so we need to better understand why that's happening. Are we having more training? Do we need more training? Are we making more errors and things? So things like that help us sustain our service. All right. All that said, sorry for not having enough pictures. I think I want more pictures here. This is a photography team. In 2023, we had over 325,000 internal Boeing. This is actually visits. So these are the number of visits that we had throughout the year. And then we had 1,318 scenes processed. So these are their 360 images that are captured, processed, and delivered. And then we delivered 153 virtual tours throughout the year. We're currently supporting 45 Boeing programs. There's currently 3 or 4 that we're not supporting, but for the most part, we have pretty much every single BDS, defense, government, space, BCA program supported, which has been fantastic. It's been neat to send out surveys and get feedback from team members that say, hey, this is great. We want more of this. We need more pictures. We need better visibility for more and more use cases. So it's great to see something like this after building it for so long and seeing that people actually care when it stops working. They use these things daily, and it really supports how they do their jobs and help Boeing provide and build better planes and better visibility and better engineering. So far, we have 7 patented technologies. We've got a few more that are going out and are in work in various stages of that. It takes forever. Right now, we have 20 dedicated team members. We've gone down as low as 12 the last few years, depending on the pandemic and things like that. But 20 seems about the right size fit for our for the needs that we support. And then we're capturing images at 5 Boeing sites each day. So we've got Charleston, Mesa, Puget Sound, Everett, Puget Sound, Renton, and then we've got down in El Segundo in Space and Launch. And then we also fly. So when we have special projects that support specific business needs, we'll fly around the world to capture images at a supplier or at a specific airline or airplane configuration. Last year, we went to both Japan and Italy to support image capture for a 787 project, which was a really neat trip for a lot of our team members to go out and see how airplanes are manufactured in other countries. All right, and this is the last slide. So lessons learned. The tools by themselves are not the solution. I think it's in the industry, we all get very excited about this technology. We're very passionate about it. It's really, really neat, but the tools themselves don't fix anything. One of the things I like to think about is a hammer doesn't build a house, right? You need the process, you need the supplies, you need the people, and the engineering to understand how it needs to come together. So the 360 tools, the visualization, the coordinates, the engineering, the specifications that we pour ourselves into is fantastic and needed and helpful, but by itself, it doesn't do anything. We've had number of examples over the years where we've built an amazing virtual tour. It's gorgeous, it's beautiful, it's done, it's delivered, and then somebody moves on, or the person moves to their program, and it doesn't get used. We've also had the opposite effect when we are tying in and having better communication understanding of how the tour is going to be used before we ever go shoot it, before we even build the requirements. So as we go into each project, one of my expectations for the team is that we understand what we're building, why we're building it, and how it's going to be used before we put together an estimate of support. And the more clearly we can define that, the more successful we're going to be. I don't want to just make things because they're pretty. I want to make things because they matter and they make a difference. And so that's the connection that I really want to take away from this presentation, is that we need to be building things that make a difference. putting something to go on the wall is great and beautiful. Putting something up to go on social media is great and wonderful. But what's the impact? What are you trying to solve? What is the why for that? All of those things matter. I'm not saying they don't. They all do, but we need to understand why they matter so that as we create that content, as we deliver it, we need to understand how we're going to be connecting that to the users. And without that, we might as well be taking pictures and putting them on our computers and not worrying about it. So understand your users and their needs, same thing. We really want to understand what their process is. So if they're going to be expected to look at the picture and smile, then great. If they'll be looking at the picture to understand how many fasteners go in what orientation and then what gets installed on top of them, then we need to make sure it's in focus. We need to make sure the lighting is clear. We need to make sure the exposure is correct. We need to make sure that the location of where we captured the images is correctly captured so they can associate it with the engineering drawings. Do we need to access the quality control records to make sure that what was installed there before didn't create any issues with manufacturing? Do we need to connect to fleet deployment? Is there any corrosion in that area? All these sorts of questions help us to understand how to build a better tool so that we can support the needs of our users. Make it simple. I forget who said it, but one of the best things I've learned over the years is it's hard to make things simple. It's very simple to make things hard. So we really want to take the time to understand the users, understand their pain points, understand the processes that's going to be implemented to use the tools. If we just put out a tour and blindly deliver something, it'll be simple for us to make, but it's going to make it very difficult for the users. So I think anything we can do to connect those dots, to understand what information the user is trying to view, to add context to, is going to add value to the use case. It also makes it easier to use. I think that's why Apple and companies like this have been so successful, is they spend so much time and money and effort understanding how users access that information. How do they move their fingers? I mean, how do we go through and find our apps? What functions do we normally use? The more information like that, the more critically we can understand that information, the better we can support our users. Taking pictures is simple. We can push it. We all can push a button, but there's a lot more to it in terms of delivering that content in a way that's going to make a difference. Don't be afraid to suggest a different solution. I think in many cases, I'll push back on a business partner that says they want a 360. Does that really make sense? Is that the right thing that you need for what you want? I think there's a lot of situations where people are asking for a 360 or a 360 video or something where, because it's cool, it's pretty, it's neat, it's interactive, but what are you actually doing with it? I think there's, in many cases, a standard video or a standard still is going to be a better solution than a 360. 360 is a great capability, but it doesn't solve everything. It's not always the right answer. So really understanding, again, that use case, questioning everything, trying to make sure that what we're delivering is going to actually make a difference. It doesn't always have to be a 360. Build solutions that drive an action. So again, that's understanding the process, understanding how the content is going to be used. And that's neat, but so what? So Boeing is as guilty of this as any other company across the world, but making technology because it's just the next shiny object is a bit of a pitfall. We spent a lot of money on HoloLens, on Google Glass, on new COTS or new capabilities that come out through the market and try to use them at Boeing. But what we stumble on is trying to buy something and plug it in without, and this isn't just VR, this is any application, this is any new tool. But we really need to understand how it's going to be used in the process before we go out and buy it and put it up on the wall and say, look, it's pretty. If it doesn't really solve a problem or it doesn't make a current process easier, then we don't need it. Let's focus on what actually matters. And quality matters. Obviously, Boeing's been in the news a lot, lots of challenges, and we're making a lot of big strides and changes in how we think about quality and being able to improve our communication up and down the leadership chains to improve our quality. And the quality is not just the quality of our products, it's the quality of our communication, it's the quality of our relationships. I think Boeing's relationships with the public, Boeing's relationships with ourselves, our accountability, and tours in many ways can be used to support that. Being able to provide context to something in honesty and accountability of showing that what we build is what we designed is where we're really going to add value. And I think that applies to many industries. It's not just making a pretty picture. It's making something that is a photographic record of what we're building, and then relating that to what we say we're going to build, to what our records are. And I think there's a lot of opportunity in the industry for that kind of thinking. And build solutions that support a need. We want to make sure that what we're building is not creating a new need. It's not creating a new step in somebody's process. It's solving a solution. I used to do a lot of technical photography before I got into building this capability at Boeing. Things like high-speed video or things like infrared. And if you think about it from that perspective, we're solving a problem. Things like, say, the bird gun. We still do a lot of certification engineering tests around bird strikes, making sure that when a bird hits an airplane, we're not going to cause structural damage to the plane to the point that it's going to fail or cause safety issues and concerns. And so, thinking through that whole process, creating a photographic record of a high-speed video of a bird hitting an airplane is graphic and probably too much information that anybody wants to know. But think of it in terms of the data. You're going to be creating a point of impact. You're going to show how that impact occurs. You're going to show the wave patterns or the what fails first. You're going to show which fastener fails first. We're going to show where that damage propagates to. You're going to show how that scene of events happens. And you can't do that with a standard still. You can't do that with a standard video. You can't do that with a bunch of stress analysis tools. You need a quantitative solution to be able to understand that sequence of events. Additionally, you're adding how fast the bird was going at impact. You want to be able to analyze the frame rate, the verified timestamp, do some math to understand what that speed at impact was, and compare that against the weight of the bird, and the impacts that's going to cause against the structure. So again, it's all understanding that use case, understanding how we provide value with not only pictures but with a solution that supports a need. All right, I feel like I've rambled on. And I think we had a couple of questions, so I will pause there. Any questions or any other comments, Scott, before I jump over to questions?
Nope, jump right into questions, please. We've got them both in questions and in chat.
Great.
You may need to click on the Q&A down at the bottom there to get the screen up.
All right, I think I'm seeing it now. Dale Dvorak, thanks. Good to see you, buddy. And we've got Jim Michael. Do you supplement the visuals with LiDAR or photogrammetry data? Definitely. We do use photogrammetry quite a bit in our tools. Things like applying local coordinate systems, like the station waterline buttock line I mentioned, to photographic images, both 360, spherical, and planar. So situations where you're stitching flat images together across a large area, like a wing or fuselage, and then applying photogrammetry to that, so you know each pixel has a defined location. Things like that enable us to do automatic plotting of engineering data and manufacturing data, and allowing the users to access that data based on what they're clicking on or interacting with. So really exciting stuff with that. Can you move in 6DoF? No, but it's not because we couldn't, it's because there isn't a use case for it. I think there's a lot of things, like for example, VR, putting on a headset and accessing this content via a headset, vis-a-vis 6DoF, is not really needed for how we're delivering the content. Our users don't really need that for accessing or making an action on their processes. So it's one of those things that we really need to do. I think there's a lot of capabilities that I would love to do and make really neat capabilities for, but if the users aren't going to need it, then I'm not going to spend the time and money to do it. Tennis balls and the protruding bolts is pretty high tech. Yes, that's a solution that actually a mechanic came up with in 787. That area that you're seeing was in the cargo area of the 787, and it's not tall enough to stand in. And so people have been wearing bump caps and hard hats for years to help support that. But adding in the tennis balls allows us to not only protect our heads and our health, but also the product. So when we bang against the head accidentally after sitting over, having bad posture for hours on end, we don't want to damage the airplane and have to replace that part. So it looks a little bit silly, but it actually is very effective. I can say from experience. Are the models displayed on the left screen created rather than scanned? Yes. So in the 3D model you're talking about, I'll go back to that one just so we're on apples to apples here. This guy. The 3D model on the left is sequentially created for each line number based on the configuration of that airplane. In other words, yes, it's each part in this. I'm going to stop this here. Each part in this is a unique geometry. It has its own life. And so what they've done is they've taken all this geometry for each of these individual parts, everything from the fastener, the bracket, and created a systematic approach to assemble all of those based on the coordinates and the design definition of the entire airplane, and assemble it into the visualization tool. Excuse me, we call IVT, integrated visualization tool, which allows all of this to be sequentially created. Again, this is the design definition. It's a different need and a different capability, but being able to equate that to the as built allow us to create a lot of value in our information lifecycle and prove that what we're building is matched up to what we're designing. Hope that answers the question. How do you deliver virtual tours to your customers? What are the hosting and access control considerations? Ooh, fun. So most of our tours that we deliver they're all internal to Boeing. We do support delivery to airline customers, but generally we think of customers as business partners inside Boeing. So Boeing is this huge own ecosystem. We all have our own content needs, and each of those also have their own access control considerations. So each Boeing employee has their own identification number based on how you access your computer. That information then gets fed into our internal security system, and then it validates whether or not you have access to whatever content you're trying to access. And so we apply those same permissions and controls to each tour that we deliver. Some of them, like first of models, are pretty wide and open to most Boeing employees. Some of them, like the defense programs, your BINs, your employee identification number essentially tells your U.S. person status, your country of origin, all those sorts of things, and those run through our security system to validate whether or not you have access to each tour. As far as external, we have two different ways to do that. We can host it internally and provide a validated authentication, so you can have a external user come into the Boeing infrastructure and access that site internally to Boeing. Or we can go through the release of information process and share that content and that whole data file package externally and give all those files to the customer. Of course, we don't like doing that because then we can't maintain the application. So when web browser technology changes or we have new capabilities that we offer in the platform, we can't update those. We can't ensure that their content is going to be sustained. The other consideration with delivering it that way is that we can't control the access for it. So if somebody leaves that on a park bench or they hand it off to somebody else on a thumb drive, we have zero control over that. So it's a little it doesn't always make sense for all the use cases, but when we can, we try to support the internal delivery system to ensure the platform is sustained, the accessibility is maintained, and that people who need to access it can access it. All right. Tennis balls in the film industry too. That's awesome. That's cool. I didn't know that. A lot of what you've described is more an engineering service and a process than an airplane product. Does Boeing have plans to provide this visualization service to other companies and might be a profitable consulting gig? Yes and no. In some situations, we've provided this capability to our suppliers, things like Spirit or KHI, Kawasaki Heavy Industries, or Leonardo, some of their companies that help provide and build part of the airplane, or we partner with to help build whatever the airframe or product is. That's been a nice way to go about sharing and communicating things. In some situations, like working with NASA, it's been a lot of fun because NASA has their own internal web hosting technology set, and Boeing has their own. And so being able to share this even via WebEx or a online sharing like this allows conference calls to be a whole lot more engaging and productive when you can zoom out, you can spin around, you can point at something and say, here's the current state of affairs, rather than the design definition is fantastic and great, but when you're in the middle of a manufacturing scenario, being able to show the physical product and even reference products that have previously been delivered and support those partnerships, those relationships with other companies, is a very powerful tool. So really excited about being able to share this kind of concept with other companies as well, where it makes sense. All right. How did you maintain configuration control over these assets? Ooh, wow, good one. Is there something comparable to the software industry's GitHub that you rely on for this? So what we actually do with this is there's a couple ways we manage the configuration control. One is we identify specifically the line number, which is sort of like the serial number on a product, the customer, the capture date, all of those required elements go into the tour. So the user who's asked us, because there's many different use cases we support. So in some cases they want just that unit to be able to go back to and say, hey, I'm looking for something that was done on specifically this unit. That kind of control and dissemination of information is super helpful. But you picked on a very important point, is that pictures don't change, period. We can update the pictures and we can add more content to them, but the original picture is a specific fixed point in time of a specific unit. So as engineering changes, and it always does, we find better ways to do things. Updating that information is a powerful tool. And one of the things that we've done with this is it's enabled things like before and after. So if we do we have some really neat capabilities. I'm sure if you haven't seen it, you should definitely check it out. KRPano has some really neat functionality where you can scrub across the picture, and if you take the picture in the exact same point, you can see kind of a before and after scrub of it. So we've taken that kind of concept and built it into our application, where you can see the structure of the airframe, and then the blankets, and then the systems, and then the control surfaces being added in, and you can keep switching back and forth between that same viewpoint between those build phases. And that enables all sorts of things like being able to pull back structure, being able to pull back different systems to see what's behind elements without having to physically remove those parts from the airplane. So configuration control is an important element of how we organize, categorize, and access these tools. Good transparency question. Sorry, Q&A tab. Where is that? Oh, there it is. Found it. Thank you. How do you maintain the same color white balance between 360 photography shots? I shot inside a helicopter hangar and got variations on white balance, even though I had a fixed Kelvin setting. I love it. Somebody who knows this stuff. So it's a fine line. We added a color grading step in our process. It's about 18 months now. And what we found is that it actually reduced the amount of processing time it took us to go between our Lightroom, which is our essentially adding our metadata into all of the images, to our stitching phase. And because essentially what would happen is we'd move into stitching before applying a color grading, and you ended up having a lot of back and forth on stitching, because in order to release the images to the retouching team, we have to make sure that the images are all common in terms of the lighting. Things like whether you shoot at night versus the daytime, obviously you're going to have big differences. So one of the things we started doing is closing all of the passenger windows. On the 8.7, you can just push one button and it dims all the windows, and it's amazing. On the 3.7, you have to go through and manually close all the windows. But enabling things like that enabled us to have much more consistent lighting around all the way down the tube. But in situations like this, where we're on the shop floor and we have different color balance of lighting between the left side or the right side of the plane based on the shop lights they installed, it gets very challenging. Also on older planes, where we have planes where we really didn't care or pay attention to the color balance on things, that planes that are much, much older, made it much more challenging. So as you move through the cabin, you'll see pinks and blues and greens and all sorts of different colored lights that really pop up that you don't see with your naked eye. So adding the color card place, there's actually a really fantastic document out there. If you look up the color card capture process, if you place that in your scene, so it's at the same distance from lens, has the ambient light falling on it relative to the location that you're going to be capturing. You can really standardize the look and feel of each of the 360s as you move through the cabin. And talking about an airframe like that, it definitely makes a huge difference. Definitely recommend implementing a color card balance in everybody's capture process whenever you can. Is the Apex software available to the public? No, it's an internally developed software that we support and develop and maintain inside of Boeing. We do provide, like I mentioned, deliverable of that of our products outside of Boeing, but the software itself was really structured and built for Boeing processes. In some cases, I think there's some neat capabilities that may apply to external things, but I think most of it is pretty Boeing specific. Are you integrating generative AI into your systems? Ooh, love it. That's a good one. Short answer is no, but I think there's definitely some opportunities there to look at. The reason we're not is kind of what I said before, in terms of we're giving a photographic record of what we built. So there's definitely opportunities for AI. Things like being able to automatically generate the nadir to drop in the tripod hole would be a huge time savings. It would mean that we wouldn't have to worry about it, and it would be automatically perfect and gorgeous and beautiful. It would reduce what takes us an hour to an hour and a half to 5 minutes or 1 minute. Great, awesome. Problem is we're not delivering what was actually built. It's creating a computer-generated model of it. For use cases, things like training or simulations or example products where we want to show a customer what it could look like, then that's great. That's perfect. Totally all for it. But in situations where we're trying to create a photographic record, a visual confirmed record of what we delivered, it won't work. Cannot work. Another challenge with AI is that to date, as far as I know, and maybe somebody out there smarter than I am knows a different story, but to date, AI systems, especially the Adobe ones, are all hosted through the Adobe Cloud. So essentially, you end up having to upload your content into a cloud system owned by another company, and then get the results back. For released information or public information, that's great, but Boeing's pretty restricted on what on that kind of use case. So things like ITAR or government programs can't ever go through that kind of process. We do have new artificial intelligence systems and capabilities being built inside of Boeing, which is great. But for generative AI, it's not really our target use case. However, visual AI, computer vision systems, and machine learning capabilities are something that we're very actively pursuing. Things like being able to visually inspect the photographic images for things that the human eye missed. Things like being able to do automated visual inspections is something that's a very common use case outside in the public domain. Things like drone inspections, or situations where you're capturing automated set of imagery of an exterior of a product, and then localizing those image captures based on where they were relative to the product, and then applying a computer vision algorithm or a machine learning algorithm to go through and identify differences of what it thinks should be there. So you can have a assisted algorithm to show inspectors where to look. Things like that are huge, huge opportunities for Boeing and for the industry. I think 360 capabilities and building that into that kind of information pipeline is a great concept. Let's see. It appears that the capture technology used here is photogrammetry, which is quite limited, CG based, polygons, cost prohibitive, and antiquated. Our technology at Waypoint allows you to create AI-generated photorealistic scenes in 6DoF, which makes photogrammetry obsolete. Unfortunately, that won't work for us. Again, we can't use computer-generated anything. We can't take an example photo and have it create a similar photo. It has to be exactly what was built for our use case. There are definitely opportunities for creating computer-generated capabilities. I agree. Some of our technology here is antiquated, but it's that way for a reason. It's not meant to be a pretty picture. It's meant to be a record. So it's kind of two different use cases. I think there's very exciting capabilities on both sides of it, but two different use cases. All right. Yeah, and I hope I'm saying it, Mr. Goldfarb, I'd be happy to, if you want to reach out, I'm happy to connect with you more and discuss that in more detail. Generative AI could blend real life and your drawings flawlessly. It could. But it's, again, not what we're aiming for. Just finished doing no-code ML. It has huge uses for you. Agreed. No-code ML is very exciting. No-code allows you to do to create sort of like systematic code bases without having to write the code from scratch. Love how that works. It's very neat. Awesome. Any other questions I missed, or anybody want to come off mute and jump in? Did I miss anything?
I think you got it covered.
Great.
Well, see, Lauren just popped up something in the chat.
Yeah, I was trying to get my video back too, but I turned it off. But I was just thinking about, kind of a futurist question. If anybody's looked at a lot of people are talking about AI and the generative. If you've seen the new text to video, specifically OpenAI's Sora, and I put the link in there. It's kind of spooky how good it is, and I'm thinking about in a future conceptual design space, if it's based upon all of the assets that you've got collected, could you sit there, headsets on, or maybe in front of a cave system saying, hey, let's have a 5'7" person walk into the airplane and walk down to seat 32A. And they'd actually create from your assets a video of that person walking down, and you could watch it from any vantage point. But go look at the videos from that if you haven't seen the text to video yet coming out of the OpenAI's stuff. It's
yeah,
pretty wild.
We actually have a lot of capabilities like that. We already have inside of Boeing, where we can simulate passenger experiences, simulate design and manufacturing processes based on engineering, so we can ingest the CAD, create a photorealistic simulation, and work through a process to make sure that the process is going to work. And then other use cases where you can simulate capabilities of the aircraft or spacecraft to customers and walk them through if the capability will support their needs. There's amazing stuff like that out there. It's great.
I was still going to ask if your simulation, those types of ergonomic studies are coming out of your finite element analysis tools and your, those types. You're not doing simulations for people with your tools yet. That's done by.
Not for the photography, no.
Okay.
No, that's not what it's meant for.
Yeah, you can see the interest in photogrammetry, I think, in just talking now, maybe lead into our conference discussion about that. But you can see the interest of, hey, I've taken these photos, they're quite, they're good, high quality.
Mhm.
How do I now get a 6 degree of freedom movement in that space? Because a lot of us are doing rather planar subjects, real estate, museums, places that a little bit of Blender knowledge, a little bit of CAD work, you can turn your photographs into pretty believable, immersive, true VR spaces and bypass, as the one person said, bypass the whole traditional gaming route where you're building things in CAD programs, or LiDAR, messing around with LiDAR point clouds and such.
Mhm. Yeah, again, they're two different needs, and it comes back to really understanding the use case for who the user is and what they need it for. Um,
I did have one question for you, actually, to reinforcing you're talking about the use case of you are documenting the as-built, dimensionally accurate conditions. Are there, I've seen this in military applications where because of that, the photography that's being taken becomes classified itself because you
yep.
can now reverse engineer or build things from that. Is there a concern that, hey, this is such a dimensionally accurate record or digital twin of this aircraft that I can go make myself an aircraft because you guys, thank you very much, Boeing.
Yes, that is absolutely a concern, and that with some of the programs, they won't let me show it. So yes, that's absolutely a thing. Um, I did want to mention one thing I didn't get to bring up is, and I don't know if he was able to join or not, but a man by the name of Federico Capasso he's from Rome, gave a talk inside Boeing last week. Is this amazing presentation about a metal lens. I don't know how many people on here are familiar with it, but it's kind of like a uh, it's a flat lens, so without the curvature, which kind of changes the entire geometry and flight path of light as it comes through the lens. But instead of passing directly through the lens, what they've done is set up a set of light capture modules inside the surface itself, which then enables you to capture the light without things like chromatic aberration. So essentially how a lens works is you've got different light coming in at different wavelengths, red, green, blue, coming through different depths of the glass. And as you converge it on a single point, the sensor, you get the light coming in at different times, and it creates this this noise effect between red, green, and blue. And so we've had lots of different lenses and glass to help address and focus and stack the light, which is a whole amazing technology stack that we've built over the last 100 years for lenses. But changing the whole base level of how we capture light is a really exciting topic that enables things like capturing the geometry of the light itself, things like the distance measurements, the depth of things, being able to capture that in the raw data itself, rather than having to post-process it and align it with something else after the fact, is a whole new technology set that I definitely encourage the community to take a look at. Again, his name is Federico Capasso and MetaLens. He's got some great TED Talks out there. There's several other technologies and companies that are starting to pursue this. It's been out there for 10, 15 years, but it's starting to become much more public now, as they've actually put into in this stuff into production. I know the U.S. government, DARPA, and other kind of think tanks have really been not just thinking about this, but building actual working capabilities around this that I think would be really exciting for us as a 360 community to start looking at, because being able to provide better dimensional data built into the raw capture allows better transparency of us, rather than having to, like you said, compile it, composite it, and then align it with CAD. It's pretty exciting technology. Oh, perfect. Somebody already put it up there. Gorgeous, thanks.
Okay.
All right.
Lauren, do you want to give a quick
Yeah, we got the conference. We're deep into the planning and execution of the conference. It's going to be at Tuscany Suites and Casino in Las Vegas, June 25th through the 27th, and we have a work day or a workshop day on Friday the 28th. It's going to be with Al Caudulo and then Keely Turner and Yu Hu. So we're really starting to pull things together. We will have things, the website and registration up and running by the middle of this month. Brian, Scott and I are working feverishly on pulling the website and everything together this week. So we should be ready to launch everything here. I think Brian was talking about the 11th. And I think we're pretty, yeah, that's a week from now. So we're looking good. It's going to include a trip to the Sphere experience, that big round dome that's in Las Vegas. It's been throwing everybody for a loop with its eyeball or all kinds of video. And going to be lots of fun. I know everybody's looking forward to it. Scott?
You want to give a preview of some of the known speakers that we have?
Let's see
You
here.
mentioned a couple, but
Well, we have one of the other speakers that's important is the team from the One Ocean SeaWorld in Abu Dhabi. That's an amusement park that's got a full 360-degree display. We will, let me see if I can, I probably might have a link here to it. No, that's not it. Let me go
well,
get
the gist of it though is that they had to build custom cameras. They were filming underwater, above the water, to create a very immersive experience. And they also bring in other elements, like when you see these lit up.
They have some drones that drop down. They have a
Right,
globe
yep.
in the middle.
Yeah, it's a really interesting experience. So we'll have live the experience of the Sphere, and we'll learn about this other very immersive experience from Abu Dhabi.
And then we also have we'll have several other options. Lauren and Stephanie Wilcox are going to be talking about ADA and some the work that they've been working on for interactive displays. We have Jeremiah's going to go into more detail about what he showed us this morning. Let's see here.
Mike Ty or Mick Ty?
Oh yeah, Mick Ty is going to talk about developing his YouTube channel and some of the things that he went through. He went through a rebranding a while back, and so he's going to talk about what he went through with that. Who else we got there? Oh yeah, well we have a couple people coming in 360 filmmakers talking about storytelling. Al Caudulo, Keely Turner, Rachel Rachel Backer, and then Matt Rawls going to talk about best business practices.
Do you have Greg Downing as well, I think?
Oh yeah, Greg Downing getting into photogrammetry.
And Martin Hopkins from Garden Gnome.
Yeah, Martin Hopkins with Garden Gnome.
And from Meta?
Oh yes,
we're working on it.
We're working on it.
We're getting there.
Right.
And there's you can't. I did talk to the local the closest Apple store, and we have worked out so that you can take and get demos of the Vision Pro, Apple Vision Pro there. UU is going to be, I'm sure we're going to be talking about that, developing content and what have you for the Apple Vision Pro at the conference. That's become a real hot issue these days. I think we got it pretty much covered there. We'll get into the Meta 3 and maybe what they might have coming down the pipe. So it's going to be a fun time, and it will be hopefully before it gets too hot in Las Vegas.
Well, it'll be inside, so.
Yes, we will be inside for the most part. And the casino, the hotel where we are going to be having it is a really nice place. I was really impressed, and we have gotten a really good rate. I can't believe the rate that we got. $72 a night. That's
The rooms are absolutely beautiful, spacious, refrigerators. It's going to be great.
and it's not a high rise either.
No.
So it's more like a resort, and the casino is pretty quiet in comparison to casinos. So it's not out there.
I think there's a pool as well.
Yeah, oh yeah, there's a
And
couple
a hot tub,
hot tubs.
4 restaurants, casino, everything you want.
They don't want you to. And there's a Lowry's restaurant,
And it's only 2 miles from the airport, which amazed me.
Yeah,
And it's a 15-minute walk to the Sphere if you're so inclined in June.
Although we will
have
provide
buses.
transport.
Yes.
yeah, we are. And the ticket does include transport to and from. So, it's like I say, it's going to be a good time. Everybody's going to, the last time they had a conference in Las Vegas, it was well attended and everybody enjoyed themselves. And I think we're going to have the same thing again. So,
Jeremiah, I don't know if you noticed the question about light field. Do you want to address that at all?
I honestly, I did respond back to him. I'm excited about light field technology. There's a lot of opportunities there, and maybe I'm out of touch with it. But last I heard, the company that was making that camera and capture system is no longer around. If somebody knows more about another company or somebody else still doing it, I would be interested in learning more about it.
okay, I think we got it covered.
All right, if there's no other questions, then we'll give it a wrap. Thank you all.
Thank you, Jared. Thank you, Jeremiah.
Yeah,
Good show,
sure.
everyone.
Thanks. It's excellent.
And thank you, everybody, for showing up.